Now we have a simple problem in front of us. So there are two poles which have lengths 35.79 meter and 39.34 meter. We need to find out by how much is the second pole longer than the first. So the length of second pole is 39.34 meters. So we simply need to subtract 35.79 meters from 39.34 meters, because this is the length of the second pole and this is the length of the first pole. So the difference will come out to be 0.55, 2.55 meters. So the correct answer is option C. If square root of m equals square root of 3, square root of n equals square root of 27, and square root of p equals square root of 243, which of these products result in a rational number? So first of all, what is square root of n? Square root of n is square root of 27, and 27 is nothing but 3 cube. Similarly, square root of p is nothing but square root of 243. And what is 243? 243 is nothing but 81 multiplied by 3. And what is 81? 81 is 9 multiplied by 9, that is 3 squared multiplied by 3 squared multiplied by 3. So this is 3 to the power of 5. So we have 3 to the power of 5. Now what is square root of m? And this is nothing but square root of m multiplied by square root of n. What is square root of m? Square root of m is square root of 3 multiplied by square root of n, which is 3 cube, that is square root of 3 to the power of 4, that is nothing but 3 squared, that is 9, which is rational. So square root of mn is rational. Square root of mp would be square root of m multiplied by square root of p. Square root of m is how much? This is square root of 3 multiplied by square root of p, which is 3 to the power of 5. So this is square root of 3 to the power of 6, which is nothing but 3 cubed. This is 27. So this is also rational. Now square root of np can be written as square root of n multiplied by square root of p. Square root of n is square root of 3 cube multiplied by square root of 3 to the power of 5. This is nothing but square root of 3 to the power of 8. This is 3 to the power of 4, that is 81. So even this is rational. So all three are rational. So the correct option is option D, all of these. Which of the following fractions represent recurring decimals? So first of all, what are recurring decimals? So recurring decimals have digits that repeat infinitely after the decimal point. So after the decimal point, we'll have digits that are repeating infinitely. So let us take up each fraction and check if they are recurring decimals or not. First, let us begin with 2 by 7. So 2 by 7, if I convert to a decimal number, this would be 0.285714, and so on. So this 285,714, this block keeps repeating infinitely, making this a recurring decimal. So this is a recurring decimal. What about 1 by 3? 1 by 3 is nothing but 0.333, so on, that is 0.3 bar. So this is also recurring continuously. So this is also a recurring decimal. What about 1 by 5? 1 by 5 is nothing but 0.2. So this is not recurring. Okay, so this terminates with the digit 2. So this is a non-recurring decimal. So the correct answer is option D, that is both A and B. Next, we have a very simple problem. We need to find the repeating part, that is the period of this decimal number, that is 213.234646 and so on. So in this decimal 234646 and so on, we can see that the repeating block is 46. So in this case the period will be 46, and if the question is what is periodicity, that would be the length of the repeating block, which is 2. But in the question we are asked what is a period, which is 46. So correct answer is option C.